Okay, we want to begin by testing whether the line given by the equation, the lines given by the two equations we see here are parallel, perpendicular, or neither. Well, if lines are parallel, they have to have the same slope. So, let's find the slopes. Now, the first equation we solve for y, and we're going to subtract 2x from both sides, and then we're going to divide by the 7 here, and we're going to get negative 2/7 x plus 4/7. That's our slope-intercept form, so we can see that the slope is negative 2/7. Second equation, if we solve for y, again, we get y equals, subtract 3 from both sides, 3x from both sides. We're going to have a 3x over here. When we divide by 11, that's going to give us, going to be a negative 3x, negative 3/11 x plus then 17 over 11. And the slope is negative 3/11. So, is negative 2/7 equal to negative 3 over 11? Well, we can do this thing called cross multiplying, which I really don't like because it doesn't reinforce something really important. I prefer to multiply both sides by 7 times 11. Either way you look at it, though, this equation rearranges to negative 22 equals negative 21. So these slopes are close, but not quite. Okay, perpendicular. The slopes would have to be negative reciprocals. Well, the negative reciprocal of negative 2/7 is plus 7 over 2. And the negative reciprocal of negative 3/11 is plus 11 over 3. Okay? Now, this isn't the negative reciprocal of this. I'm sorry, yeah. Let's be careful. Okay, the slope here is 2/7. Okay, so I was right. 2/7 is not the negative reciprocal of negative 3/11 because negative 2/7 is not 11/3. It's not even of the right sign. This is positive, this is negative. Okay, the negative reciprocal of negative 3/11, well, we just said it. Okay, or the negative reciprocal of negative 2/7 is 7/2, and that's not 3/11. Negative 3/11. Negative reciprocal of the first equation is 7/2. The slope of the second is negative 3/11. very clearly 7/2 is not equal to -3/11. With the -2/7 and -3/11, the two slopes, these slopes were close to being parallel. We had to do a little arithmetic to verify that this equation gave us this equation, which tells us that this isn't quite true. Here, it's not even close. This is positive and this is negative. So the slope of the first equation is not the negative reciprocal. I'm sorry, the negative reciprocal of the slope of the first equation, which is 7/2, is not the slope of the second equation, which is 3/11. Okay, so negative reciprocal of the first slope is not equal to the second slope. So these are not perpendicular. So they're not parallel, they're not perpendicular, so they're neither. Okay. Now looking at the example of number 29, we want the equation of a line through the point -3, -2 that's parallel to the line 2x plus 7y equals 4. The slope of this line is -2/7. Okay, so the new line must have the same slope. To be parallel. So find the line. We're asked for a line through -3, 2. -3, -2. With slope -2/7. Okay, whether you draw the fundamental triangle or use the point slope form, or some other method, and I'm not going to go through the details of the method, first because I don't have room, and second because that was done on a very recent video, this one preceding this or the one before that. But using the usual methods, we're going to get y minus -2, y minus the y coordinate here, equals slope times x minus the x coordinate of this point. And this would be consistent with the point slope form, but it's also what you get if you do the two fundamental triangles after just a couple of steps. This gives us y plus 2 equals -2/7 x plus 6/7, so that y is -2/7 x plus 6/7 minus 2. Now minus 2 is -14/7, so we have -2/7 x minus 8/7. Write my x in there. Okay? And if I've done my arithmetic correctly, this equation does go through the point -3, -2. And we can check that. If x equals -2, -2/7 x is plus 4/7. And if we add, I might have another arithmetic mistake. Okay. I was careless with my signs. This is x minus -3, which would be x plus 3. -2/7 times 3 is plus 6/7. is negative 2/7, negative 6/7. So this should have been negative 6/7. And then when I subtracted the 14/7, I would have gotten negative 20/7. So now if x is negative 3, we get 6/7 here, and negative 20/7 gives us negative 14/7, and 7 goes into negative 14, gives us negative 2, so y would be negative 2, so there we have it again. So emphasizing the need to check. Okay, we check out this equation to see if it contains this point, and we look carefully to make sure the slope is equal to the slope of this line. And then we can be more confident in our solution. Okay. Now the equation of a line through 5, negative 2 perpendicular to this line. The slope of 3x plus 4y equals 17 is, as we saw previously, because we used the same equation here, but we can see that if we put the 3x over here, it'll be negative 3x divided by 4. The slope is negative 3/4. And that isn't the same as the equation we used over here, but okay, that is the slope of this equation, as you can verify if you solve for y. Okay? So a perpendicular line then has slope negative reciprocal of negative 3/4 or 4/3. So our line passes through 5, negative 2, has slope 4/3. Now checking my time here. If we go over 15 minutes, it becomes a royal pain, but I think we have time. So the equation is, and I do advocate doing the equation with fundamental triangles and then doing it with one method or another and seeing that it works, because this reinforces what the equation of the line means. But the equation is going to be using slope-intercept form, or the form that we get from the fundamental triangles after just a couple of steps. And if y minus negative 2 equals 4/3 of x minus 5. So y plus 2 equals 4/3 x minus 20/3. And then subtracting 2 from both sides, 2 is 6/3. So we're going to have 4/3 x minus 26/3. Okay, we think the slope is right. Verifying that if we plug in x equals 5, we're going to get y equals negative 2. Okay, well, if x equals 5, then 4/3 x is going to be 4 times 5 over 3 20/3. 20/3 minus 26/3 is negative 6/3, and negative 6/3 is negative 2, so this checks.